Hi, I'm Michael Fitzgerald, Director of NextAstro, and I'm going to show you how to run an exoplanet dataset through Exotic, which comes out of NASA, the Exoplanet Watch team, headed by Rob Zellum. Basically, though, before you get to that stage, you will have had to observe an exoplanet transit or have a transit shared with you. The quickest way to get an exoplanet transit is to find a telescope that you want to use, go to Exoplanner, and you can flip through the nights and see what transits are up in the sky at that time, and if they're test transits you can add those in as well. You look at the visibility chart, when is it up, when does the transit happen, etc., and then you can press schedule. So I've run through that very quickly, and if you didn't understand it, that's okay. I was just showing you, here is where you probably will get your transit from, unless someone's shared you a transit to work with. But once the transit's been observed and it's got into your archive, you go to the data center. Now, this is where most of the manipulation of data happens, and it's sort of where we store this astronomical data ready for you to use it. So you have your own drive space, which is here, and you can click in here. I have a lot of stuff in here because I throw things around a bit. If someone shared you a transit, it'll be in your shared drive space, and it will look very similar. If you've observed your own transit, it will be in data inbox. You see here I've got quite a bunch because I've been playing around with stuff. And they'll usually come with object name, the night of observing, and the telescope. And that will, all of the data will be kind of bundled into that directory. So you see we've already tested some of these so far, so I'm going to pick one that's good so I know it works. We can click into that directory. You see a whole bunch of stuff as well. The FITS files this is the format that astronomers use to carry their images around. You can explore that in more detail later on. It's not just an image, it's a lot of metadata as well. But basically, if you have all your FITS images in this folder, you can press Run Exotic in this folder. So Exotic is Exoplanet Transit Interpretation something. I can't remember what the C is for. Code. Yes. So we'll click that, and we'll wait a little bit. So there can be hundreds, sometimes 1,000 separate images. And what's happening when you press this button is it's making you a little temporary, temporary directory, making a little temporary directory on the server to put your files in to play around with them. So you never really kind of play with the original files. You always use a copy, just in case you mess it up. So here we have, this is an image from the first FITS image in your folder. It automatically gets an image of it and picks the brightest 20 stars around your target. It seems to also have picked my target. The target's generally in the center most of the time, because that's just how you point the telescope. But these are candidates it's shown you. But you don't have to pick these ones. These are just there to help you out, basically. Now you notice with my cursor goes over the image, it has an X and Y. So X is, how many pixels from the left over is it, and Y is how many pixels down from the top is it, basically. The RA and DEC is the celestial longitude and latitude, so it's star coordinate. It's usually how we point telescopes. That's a very long story. But basically you can use the mouse wheel to roll in. You can click and drag and move around, so you can actually get a better idea of what's happening. One of the things you probably want to do is check, is that the star I want to look at? You can have a look at a picture of the star field and go, yeah, there's a star here and that star. Okay, this looks like the right star. Or you can hover over it, right? And you've got that right ascension and declination. And you can compare that to what you expect it to be. So the NASA Exoplanet Archive or Exoplanet Watch or Strathmore, whatever you're using will usually have the RA and DEC. You can compare if it's close or not. It's in degrees here. And so yeah, where you click, it updates your target star. So basically, you can click your target star on here. The comp stars, well, that's a long story, and I'll leave that perhaps up to whoever might be helping you through to go on a long diatribe about common stars, but basically you have your target, which I just selected, select your target. That's the most important bit. The other important bit is you don't just measure your star here. You don't measure the brightness just going from the star. Clouds can come in, focus can go wobbly, all sorts of things can happen when you have this big waterlogged atmosphere above the telescope to actually alter your image. It's not really a problem for space telescopes, but we're not in space. So, but whatever's happening to the target star is usually also happening to the star that you're comparing it to. So you pick, I like to pick a whole bunch of them. Some people like to pick one. Exotic likes one comp star. And so you pick one that you compare it to. But actually, even though Exotic only wants one star, you can give it 10 stars to select from. And that's what all of this reason there's 21 stars here. Because instead of you having to hover over each of the stars and figure out what the x, y, and coordinates are, they are actually just in the list down here. Okay, so you have target, you clicked on it with much more care than I just did then. You have all of these comp stars here, and they're listed down here in the x and y pairs. The flux is how many electrons generated from the light coming in did we collect. It's a short version. Basically how bright it is. Now when you come in here, usually the server will have gone and picked up all of the known parameters from NASA Exoplanet Archive for you, because it can be quite tedious and prone to typing in the wrong thing if it doesn't. But sometimes these can be wrong. So you'll want to check this against online values. But you're probably safe to assume that they're okay, because they actually come from NASA Exoplanet Archive. Down here, you have, this is sort of the metadata I was talking about with Fitz headers. You want the information about the observation. So it's all well and good to say you're measuring a star and here's a transit or whatever, but if they don't know where you observed it from or what time, what kind of camera, people need to know that when they're considering whether to include your transit in a data set and whether it's accurate, etc. So you have all of this information. If you have an observer code, which you won't, well, maybe you do. You can go and get one if you like. Observation date, at the AAVSO. Go off and Google that. But this other stuff comes along for a ride with the images. It's usually stored with the images. So this is automatically filled out from your image. Usually you get the star distance and how fast it's moving, proper motion, from Gaia. But this automatically pulls that in as well. But you should check that. There's a few options here that after you've played around with it a little bit, you might want to turn off and on. But for the moment, I'd go with the defaults. And then we get down here to all the different comp stars. So basically, these are filled out 1 to 10 from this list up here. But you might want to go check through all of the comp stars, and you probably want to get rid of 11, which is probably not on your list anyway. But if it was 5, that's pretty close to target. So you probably want to make sure that comp star isn't in this list here. So this list here is going to be sent to Exotic as the list of stars that it's going to assess as candidates to be the star you measure the transit from. So I think that's most of this page. The target star is here, conveniently under here, so if I can click it over here, you see the RA, DEC, and XY things change. Let me just put that back there, so easy if you zoom in to get it right. There we go, bang on in the center. So we filled all this out, and we don't have to put a save name or anything, but we can save a version for later on. So press save inits, which is initialization file, and run Exotic. So what that does now is takes all those options you just selected, and now it's going to run Exotic on your Fitz files. And this can take quite a while. So what I'm going to do is pause it in a second. But basically what's happening in your browser here now is that the code that you may run on your computer, or you may run on something online like Google Colab, It's just the same here, except it's running on the server, NextAstro Server, but it's outputting the text into your browser. Now what I'm going to do, because it can take a while, I'm going to pause it and then come back and explain what went on. And presto, I'm back. But in between there, it actually was about 15-20 minutes. I went down and ordered some shopping. So it's a good time, once you get this running, to make yourself a coffee, go have some lunch. Especially if you put more comparison stars, which makes it run slower. Anyhow, here we have, welcome to blah blah blah, starting reduction process. There's a lot of stuff here, and if you haven't seen a lot of this stuff before, it's going to look like hieroglyphics. Eventually it makes sense though as you go through your astronomy career. Here it's kind of plate solving, so it's figuring out where the image is pointing. Then it goes through and checks each of the stars you've picked as comparisons to see if they're variable. Then it goes through and aligns all the images together. Now this is the bit that took a long time. Look at all those images. There's a lot of images. So I did all that, and down here it's kind of figured out what comparison star it's going to use. Goes, oh yeah, I'm going to use that one with this size circle and that size annulus. So when you measure a star using aperture photometry, you put a circle around it, and the circle has to kind of cover the star, but then the sky can be bright. So you have this other thing called an annulus around it to estimate the sky. And they're two different size circles. Then, so it's measured that, and it'll have lots of dots, hopefully looking like a transit. And then it fits an actual light curve model to the data. So it can actually calculate what you'd expect to see for a star that's this big and a planet that's big, and if it goes in front of it, or if it goes in an angle, or if it's this far away, and how fast, and etc. So it fits that model. It actually fits thousands of models to get the best model to fit to the data that you just calculated. And it gives you all this stuff, which is your final results. Gives you the value it figured out and the plus or minus. Now it's a whole other video to go into detail about what all this stuff means. This is when it happens, how big it is, basically, what angle is the orbit on. This stuff's to do with the atmosphere. That's how scattery your dots are, blah blah blah, and how long it went for. And then it's gone down here in the reduction process. But in our code, in our server website thing, it does a little summary of the results at the top, which I was conveniently hiding from you. So here's the dots and the measurements from all the images. The red line is the fit through it. The blue is just to guide your eye, just the average of all the dots around it, so you can see it's not fooling you. Although this is a fairly obvious transit. There's the results again. Triangle plots. Probably need another video, but it's just like how certain is the timing, the inclination, and the size. Longer story. But if it's a circle, that's good. And that's it. And then there's a start again. Now you can save the zip out as a file, but you'll notice that if you accidentally go, and press the button and it goes away, that's fine. Don't worry. Go into my drive space, go down to the folder, and you'll find when it's finished to run, it will put it in a folder for you. So this is the one I ran. It's 2:26 now, and it finished at 2:15 p.m. So you can click in there, and there's all of the results, including this text file, which is essentially exactly what was on that screen before. So everything's stored once it's run. Also, if you accidentally close the window and it's still running and you can't get back to it, doesn't matter. When it's finished, it will make this folder and put it here. So that browser looking in at the code running, if you close that browser, it doesn't stop the code running. So you could close it, shut your computer, go home, catch the bus, and come back, and you should, by rights, have the results here. It has your final light curve, your AVSO submission thingy. The original settings you sent to run the code. Once you're here, you might want to fiddle around with some of the settings. And in the temp, there's a lot of plots that will definitely need another video to go through. But there's sorts of sanity and calibration plots and all sorts of things. But the important stuff is at the top. So that is how you run exotic on data that you got from one of the NextAstro telescopes or has been shared with you in your shared drive space. As you can see, I don't have anything in here because nobody likes sharing things with me. But it'll look exactly like here. So enjoy.